Good morning, students. And so let's take a look at our Chapter 2 homework. Now notice here, I've missed the due date for Chapter 2. Oh no, my homework is late. Doesn't matter. I can just click right here and go in and do the homework, right? So remember what I told you before, to get full points, you need to click and read through the chapter text and look at the video that's provided here. So both of those are point questions. But let's look at these 8-point questions, these 8 questions that are worth points. So for chapter 2, by the way, this has to do with the quiz that's due tonight, so you might want to look at this stuff. The following contingency table shows data from a shipwreck. Here is a two-way table of those aboard the ship, classified according to the class of ticket and whether the ticket holder survived or didn't. What types of variables are these and why? Okay, so somebody's either alive or dead. That's not a numerical number, right? That is a label, so it's categorical. Whether the passenger was in first, second, third, or crew, again, those are labels, so they're categorical. So both of these are categorical types of data. The pie chart summarizes the genres of 125 first-run movies released 1 year. Is this an appropriate display for the genres? Why or why not? Okay, so this is a pie chart of 125 first-run movies released 1 year. So this is 100% of the movies. We use a pie chart when we are dividing up 100% of something, right? So yes, each movie falls into one category and no categories overlap. Now, something could be, like in the real world, something could be both a comedy and a thriller or something like that. I would assume, I don't know if it's classified that way or not, but here we've divided them up into that primary category. So they fit into one category, nothing overlaps. That's correct for a pie chart. Which genre was the least common? We look for the smallest piece of pie, and that would be drama in this case. The pie chart given to the right and the bar chart given below summarize the movie genres of all the films shown in a suburban theater over the course of 1 year. Complete parts A and B. Were action, adventure, or sci-fi fantasy films more common? All right, so I'm going to look right here. Action adventure goes to, it looks like about 19, and sci-fi fantasy goes to about 21. So it's, now notice that it's easier to read than right off of here. Comparing those two pie slices, it's actually kind of hard to see which one's bigger. So this is a case where the bar chart makes the task easier because I can clearly see which bar is bigger. Is it easier to see that in the pie chart or the bar chart? Well, we just said that. That's going to be the bar chart because it's easier to tell size differences of the bars in the chart. The slices of the pie are too close in size. A movie association rates each film to designate the appropriate audience. The ratings are G, PG, PG-13, and R. The ratings of the 20 top grossing movies in 4 different years are shown in the accompanying bar charts. The pie charts show the same data but are unlabeled. Match each pie chart with the correct year. Okay, so I got to click here to see the bar chart. All right, so here's my bar chart. Okay, sorry about that. Had to take a quick text message, but we're back now. All right, so let's see what we've got going on here. So the ratings of the top 20 grossing movies in 4 different years are shown in the accompanying bar charts. Okay, that's right here. The pie chart shows the same data but unlabeled. So I'm matching the pie chart with the correct year. I've basically got to figure out Which pie chart belongs to which graph? Let's make this a little bigger so maybe we can see both at the same time. There we go. Okay, so now notice that in year 1 and year 2, the blue is the biggest piece, but it's not in year 3 or 4. So year 1 and year 2 have got to be either here, this one, or here, because those are the 2 years that have the biggest piece. Now, how else are we going to determine? Well, notice that in year 1, green and red are about equal, but in year 2, the red's a little bit bigger. So green and red being equal would be here. So that looks like year 1. That looks like year 1. Okay, let's try moving this one. And so year 2 would have to be the one where red's a little bit bigger. Yeah, there we go. That one took. Okay. So I gotta drag it down below it kind of a little bit. Sometimes this program can be a little bit fussy. So just work with it, guys. Figure out what you need to do to get it to take. Okay. Now moving down here. So years 3 and 4, notice that yellow is the biggest piece in all of them. But notice that the red is almost the same, but here there's a big difference. And notice that the blue is pretty close to the red in year 4, but it's teensy tiny. It's the smallest piece in year 3. So the blue being the smallest piece in year 3 would go here. So my year 4 must be here. All right, let's close up our chart. Okay, and so hopefully that makes sense why that's the case. An article reported on a school district's magnet program. Of the 1,581 qualified applicants, 803 were accepted, 274 were waitlisted, 504 were turned away for lack of space. Find the relative frequency for each decision made and write a sentence summarizing the results. Find the relative frequency of qualified students being accepted. Okay, so we talked about relative frequency in the video. The relative frequency, recall, is, this is of accepted. Accepted is right here. So this is 803 out of the total 1581. So I'm going to take 803 and I'm going to divide by 5081. So let's go over to the calculator. 803 divided by 1581. And we get 0.5079. So I want to round to 1 decimal place. So if this is 0.5079, rounding to 1 decimal place, I'd look at the second one, and this is less than 5, so I'd round down, so it's 0.5. I'm going to go here. I'm going to type in 0.5. Oh, I'm sorry. I didn't read. They put the percentage sign, so I need to move the decimal to, I multiply by 100, which is equivalent to move the decimal 2 places. So 50.79, 50.79 would round to 50.8%. Okay, always look, 50.8%. Always look to see what they're asking for, because if it just says relative frequency, the frequency is a number between 0 and 1, and to get the percentage, and since this has the percent sign, we're going to do that. We multiply that result by 100. Okay, so let's check that. Let's clear this. Now, the relative frequency of waitlisting qualified students. Okay, waitlisting right here. So this time we're going to do 274 divided by 1581. All right, so let's bring that out. 274 divided by 1581, and we get 0.1733. 0.1733. So I'm going to go back over here. Let's add that in. 0.1733. Okay, so again, now times 100 would be 17.33%. We're rounding to 1 decimal, so we look at the second place, and it's less than 5, so I round this down to 3. So I'm going to make this 17.3%. Find the relative frequency of qualified students being turned away for lack of space. Turned away for lack of space is 504. So I'm going to do 504 out of the total 1581. So let's go ahead and calculate that. 504 divided by 1581. And we get 0.31878. So we're going to call that 0.3188. 0.3188. 0.3188 goes right here. Okay, so I'm going to move the decimal over 2 places, right? Because I times by 100, and that gives me 31.88%. Now, I'm rounding to 1 decimal, so I look here, and it's bigger than 5, so I round up that to 9s. So I'm going to make that 31.9%. Select the statement that best describes the relative frequencies. Of qualified students, 50.8% were waitlisted. Well, waitlisted, no. That's not right. Of qualified students, 50.8% were accepted. Yep, that's good. 17.3% were waitlisted. Yep, that's good. And 31.9% were turned away due to lack of space. It sounds like that's right. Of qualified students, 31.9% were accepted. Nope. 17.3% were turned away for lack of space. Nope. Right? That's not what we found up here. So we're going to choose answer B. The Centers for Disease Control lists causes of death in the United States during 2010. Each person is assigned only 1 cause of death. Okay, so here's our cause of death right here. Notice that I can click right here to open it in Excel or StatCrunch if you're using StatCrunch, but I'm not teaching you how to do it because I'd rather you use Excel, because in the real world, you're not going to have access to StatCrunch, but you might have access to Excel, okay? All right. So is it reasonable to conclude that heart or respiratory diseases were the cause of approximately 30% of U.S. deaths in 2010? Okay, so this is the Center for Disease Control's list cause of death in the United States during 2010. Each person assigned only 1 cause. Okay. So this is cause of death. Here are my percentages. So respiratory diseases is 5.6% of US deaths in 2010. Okay, so why are they saying 30% for respiratory? Reasonable to conclude that, oh, heart or respiratory. I didn't see the heart or. Okay. Heart or respiratory diseases. So heart disease is right here, 24, and respiratory disease is 5.6. So if I add together 24.2 plus 5.6, we get 29.8. That's almost 30%. So that seems like it's reasonable, doesn't it? But notice that it says each person is assigned only 1 cause of death. Is it possible that I might have both heart disease and a respiratory disease? Maybe I was in both categories and, you know, it's not mutually exclusive. It could be that maybe I had cancer and heart disease, and even though the cancer would have killed me eventually, right? The heart disease itself is what killed me, okay? So there might be more than 1 condition affecting a person, but the actual cause of death is the one that's listed here. So here we're going to say there is the possibility of overlap. So no, whoops, there, it was the last one. No, there is the possibility of overlap between the categories. Actually, but since they assigned only one cause. There is no overlap for this chart. So yes, because no possibility for overlap there. Okay. What percentage of deaths were from causes not listed here? Okay, so notice that I added up these two and I got 29.8. That was here and here. So let's add on the others. So 29.8 plus 23.3, and we get, carry the 1, 53.1, so that took care of that. Now let's add on the 5.2. And that took care of that. Now let's add on the 4.9. So we get 63.2. So 63.2% of the deaths are accounted for by these categories. So 100% of deaths that occur minus the 63.2 that we know about. So this would be 0.8, right? Because that's a 10. This is a 9, subtract the 3, and we get a 6. This is a 9, subtract the 6, and we get a 3. So 36.8 is what remains. So let's type in here 36.8. All right, because we're talking about 100% of deaths, and we're removing what we've accounted for. Select the diagram that represents these data. We've only got these two choices to occur from. So accidents, notice, is the smallest portion, so it should be the smallest piece of the pie, not the biggest piece of the pie. So if those are my only two choices, I would choose there. All right, now, having said that, notice that this has 1, 2, 3, 4, 5 categories, and this has 1, 2, 3, 4, 5, 6 categories. That other is that 36.8%, the remaining. I can't use a pie chart. Excuse me. I can't use a pie chart if it doesn't go to 100%. So this one that has only 5 categories, we know that doesn't total up to 100%. So this is absolutely wrong to use a pie chart in this case. I can only use the pie chart when it goes to 100%, right? So I do not want to choose this first one for those two reasons, right? Because it's missing that. Not only does it not show the percentages correctly, but it is missing the remaining portion that would total it up to 100%. Without 100% there, I can't do a pie chart. Okay. The table to the right summarizes 383 films from a certain year that have been classified into a genre and have a rating. Complete parts A through D below. Okay, all right. So what percentage of these films were rated R? So notice that this is the column for rated R. So my total rated R is 178. Out of the total movies is 383. So if I do 178 divided by 383, I get 0.4648, 0.4648. So now if I times by 100, that'd be 46, excuse me, 46.48%. So we want it to 1 decimal place. So I'm going to round this to a 5 since that's bigger than 5. Okay, so 46.5%. 46.5%. What percentage of these films were rated R comedies? Now, rated R, we know is this column. Comedy is right here, so that's 40. Whoops. That's the 46 is the intersection of those two. So 46 out of the 383. So if I do 46 divided by 383, I get 0.1201. 0.1201. So that's 12.01%, right, after we multiply by 100. So I'm going to round that to 12%. Okay, let's type in there, 12%. Okay. What percentage of R-rated films were comedy? Now, notice that these were both what percentage of all films, what percentage of all films, but this is what percentage of R-rated films. So since this is the percentage of R-rated films, I want to choose the 178 as the total in the bottom. So we're going to go divided by 178. So in the top, the comedies are 46, so 46 out of 178. Let's figure that out. And we go 25.84, 25.2584, 0.2584, 0.2584. So again, times by 100, and it becomes 25.84%. This is less than 5, so I'll round that to 25.8. Now, let me point out to you again what the difference between these two questions is. These two were both saying what percentage of all films. But this one was saying what percentage of just the R-rated. So I look in the R-rated column, and the total there is what goes in the denominator. What percentage comedies were rated R? Okay, let's go ahead. All right, what percentage of comedies? Now, comedies are in this column. Comedies are right here. So this is the total I want to use. So in my denominator, I want the 109 because it's saying what percentage of comedies. So the total comes from the comedy total. So 109. And then they want to know what percentage of comedies were rated R. So the rated R column is right here. So that's the 46, right? So 46 out of 109. So let's go over to our calculator. And I'm going to do 46 divided by 109. And I get 0.4220. 0.4220. So now again, if I times by 100, we go to 42.20%. So 42.2%. Okay, let's clear this now. Prior to graduation, a high school class was surveyed about its plans. The table displays the results for white and minority students. The minority group included African American, Asian, Hispanic, and Native American students. Complete part. Find the conditional distributions, percentages of plans for the white students. So here are the white students in the first column. So I want the percentages All right, so we've got here, I need to total these, so we're going to do that by hand. So 76 plus 30 is 106. 106 plus 8 would be 114. Plus 15 would be 129, so 149. So there's a total here of 149 here. And then going across, you know what? This is going to be easier in Excel because I'm afraid that I'm misadding something in my head. So let's just open it up in Excel. Okay. And I'll teach you guys a little bit about how to use Excel at the same time. So this works out. Okay. So now notice that I can just go equals, add up, if it'll, equal, oh, enable editing. Whoops. Okay. Equals sum. So I want to sum the column above it. So I'm going to go from B1, whoops, B2 is the first number, and then a colon to the end of the number. So B6 gives, and see how it highlights the numbers I'm adding up. And there's the 149 we added up in our head. So let's do the same thing here. We're going to go sum C1, C2 through C6, and it sums there, right? So I'll put the total here. And then these are going to be the totals also. So we'll go to here. So we're just going to repeat the same thing. Sum well, I don't need to write the sum when it's just two numbers. B2 plus C2. And notice that if I do that, then I can just drag this down and it'll fill in all of the other totals correctly. See, it advanced to B4 plus C4, okay? So that adds all those totals. And so then if I add these totals going down, I'll go sum D2 through D6. Notice that should match this plus this. These two added together also give me the 200. It's the total of this column and this row, okay? All right, now I wanted the conditional probabilities of the white students. So that means that I want to know what percentage of white students did each item. So right here, I'll just do conditional probabilities. And so I can take 76, and so that's B2, and divide by the total. The 149 is how many white students there were. I could either type in 76 divided by 149, or I can go the $ symbol is like what holds that formula item that follows in place. So I want to keep column 1 fixed at B, and I want to keep place 7 fixed. I don't want that to change. But now see, notice that if I scroll down like that, it fills in the other. This is now B3, so the 30 divided by 149. This one is the 8 divided by 149, like that. So that's just a quick way to work with Excel. Okay, so here are our probabilities. So let's go back to our do homework. So the ones that attended first year college, I think that was 51%. 51% right here, times by 100. Times by 100, that's 20.1%. Military, times by 100, that's 53.7%. Employment. Oh, I'm sorry, that's not. Notice that's 0.05. Whoops. So that should be 5.4%, because when I multiply by 100, it goes to 5.4. Sorry, my eyes skipped on me there. So let's change that, 5.4. And then employment is right here. So that's 10.1% when I multiply by 100. And then other is right here, so 13.4%. Find the conditional distributions for the minority students. Let's do the same thing there, but this time, I'll move over here so we can say conditional. I want to take the this item right here, so C2, and divide by its total, 51. So static C, static 7. So that's 49%, right? So we're going to go back over here and we're going to go 49%. And the 2-year college would be 19.6%. And the military would be 5.9%. And the employment would be 9.8%. And the other would be 15.7%. Create a graph comparing the plans. Okay, create a side-by-side bar chart showing the conditional distributions in blue and the conditional distribution of minority students in red. Okay, we gotta see more. Okay, so I want to, oh, by the way, so to create this, right, I can just go equals F2 times 100, and then bring that down, right, those are our percentages, and equals H2 times 100, and bring those down. And those are our conditional percentages. And then I want to create a bar chart out of those 2 columns that are right there. So actually, it's easier if I have them side by side. So let me take, I'm just cutting that and pasting it right here. And then we'll cut this and we'll paste it right here. Okay, so now if I highlight those, see, and I go to insert, and right here is my bar chart. I can just do the recommended bar chart right away, and it'll insert like that, and then go through and adjust it. So I would give my chart a title, and I would label right here, I want titles for the axes, so I can type in this is the percentage, and then down here I would label this the different categories. So if I want all of that filled in, notice that before I highlight it, I could take these words, put them right here, and put at the top here like distribution of student outcomes by ethnicity. Something like that would be an appropriate title, something along those lines. So you just highlight all of it and go to insert bar chart, and it's gonna, it was supposed to fill in those titles. I don't know why it didn't. Let's see if it does it if we put them on there. It does not. Normally it used to. Okay, I apologize for that. So I'd have to type in my title here and then type in each of those axis titles, but it did fill in the at least the groupings for me. Okay, so this shouldn't, that's where it put it. So this is now wrong. So I would want to put the key correctly. So just don't highlight the title when you put it in. Okay, so we want one that looks like this. So when we go back over here to our choices, notice that both of them being about here is what matched in our chart right here, right? These were about the same. So we can see the only chart that does that is this one. Do you see important differences in the postgraduate plans of white and minority students? There is no more than a 5% difference in all of the categories of postgraduate plans for white and minority students. So there is little evidence of an association between race and postgraduate plans. In other words, if we look back up here, notice 51, 49, 20, 19, 5.4, 5.9, 10.1, 9.8, 13.4, 15.7. They're all doing the same thing. It doesn't matter the ethnicity. These numbers are so close to each other. They're about the same. Okay. Since similar question popped up, I know I'm done with the homework for this section. So let's go ahead and move the page. Now, as I pointed out to you, if I go back to my score on the assignments, I see score. It shows me I only got 80%. What's wrong? Why didn't I get 100%? We got everything right. Well, notice that when I go in here, I can either review and practice or I can improve my score. So I want to improve my score to 100%. All right, let's look right here. Oh, everything looks good here. Oh, wait, I didn't look at these. That's why I only have an 80% on the homework. All right, guys, hopefully this will help you get through that chapter 2 homework, and let me know if you have any questions.